I was at a baseball game recently and it was hot. I was sweaty just sitting there trying to hide from the sun under an umbrella. I checked the temperature and was shocked to find that it was only 78 degrees. I would have guessed about 10 degrees more than that. The weather I was experiencing wasn't well represented by the temperature or even the heat index, but there is a weather parameter that reflects the full picture of that hot day at the diamond. It's called the wet bulb globe temperature. The wet bulb globe temperature attempts to describe how hot it is and the potential for heat-related stresses. The problem is, it's a mouthful and isn't used by most people. A more common indicator of heat-related stresses is the heat index. Let's break down the differences between the two. The heat index is a feels-like temp calculated from the temperature and humidity. A temp of 95 and a dew point of 70 yields a heat index of 102. So a miserably humid heat is well represented. But here's the kicker. The heat index assumes you're in the shade. Direct sunlight can add as much as 15 degrees to the heat index. That's where the wet bulb globe temperature comes into play. This is also determined by temperature and humidity, but the temperatures are measured in direct sunshine. In addition, it factors in wind speed, cloud cover, and even sun angle. The wet bulb globe temperature is the highest with clear skies and calm winds. It goes down as cloud cover and wind increase. The Twin Cities National Weather Service office has a page dedicated to the wet bulb globe temperature. You can check the forecast daily. As the map moves into yellows, oranges, and reds, heat-related stress increases. The best way to stay safe in the heat is to move plans out of peak heating hours, take frequent breaks in the shade or AC, and stay hydrated. Paying attention to the wet bulb globe temperature helps sports teams stay safe and spectators stay comfy. Play ball! Lake Superior keeps it interesting for those spending time near it. When it comes to how the lake affects our temperatures, the main factors are the time of year and the wind direction. You're probably familiar with us talking about it being cooler by the lake. One great example of this was June 14th, 2022. There was a 50-degree difference in the heat index from Park Point to Hayward. A significant cooling effect like that requires a huge temperature difference between the lake and the land. The average surface temperature of Lake Superior is in the 40s well into June, so a wind off of the lake can make a big difference in spring and early summer. The effect lessens by late summer and early fall when the lake starts to catch up to the air temperature. Because the land heats much faster than the lake, air rises over the land and creates low pressure. The cool waters bring sinking air and high pressure over Lake Superior. Since air flows from high to low pressure, this creates a lake breeze circulation. This is why the east wind is more common near the shorelines in the warmer months. The lake breeze develops when there isn't a stronger weather system to take the steering wheel on wind direction. The process can reverse at night and in the winter, with frigid land temps and warm open waters generating a land breeze. It isn't always cooler by the lake in the summer. In fact, sometimes it's warmer, but the reason for this isn't Lake Superior, it's the topography. Downslope warming is when air warms as it descends in elevation. The temperature rises at a rate of 5.5 degrees for every 1,000 feet. The elevation difference from the Duluth International Airport to the Sky Harbor Airport is 800 feet, allowing for downslope warming of up to 4 degrees. So, on a hot summer day with 91 on the hill, a gentle east wind can keep the temp by the lake at a cool 63. But if a breezy northwest wind kicks in, it can be even hotter at the Sky Harbor Airport than it is at Duluth International. Lake Superior can also be a source of warmth overnight. On the morning of September 13th, Superior had its first freeze of the season, but temps near the lake stayed over 10 degrees higher in the 40s. So, Lake Superior's influence on our temperatures is nuanced and constantly changing. But that's one of the things we love about the greatest of the Great Lakes. Of all the curveballs Lake Superior can throw at us, one of the most interesting and most impactful is lake effect snow. It all begins with cold air. A strong temperature difference between the warm waters and frigid air above causes the air to rise and clouds to form. In this scenario, the lake is a source of instability. In the warm months, with a cold lake, the opposite is true. When the temperature above the water is warmer, Lake Superior can be a source of stability, keeping air from rising. That's why rain can sometimes fall apart as it approaches the shorelines. The lake winds pull the rug out of unstable air moving in. In the cool season, we don't get lake effect from just any cold air. The temperature difference we need is for the air about 4,000 feet up to be at least 13 degrees Celsius colder than the surface of the water. Once the snow starts forming, wind direction determines where it falls. The greater the distance being traveled over the lake, the better. The South Shore Snowbelt gets it more than anywhere else in the Northland because northwest winds are the most common. But an east wind can direct lake effect snow along the North Shore and in the Twin Ports. An example of this was in January of 2022. Reports range from Duluth's official 7.7 at the National Weather Service office to only 2 inches a couple of miles south. Let's think about snow as powdered sugar on a pancake. When a weather system brings snow, you tend to get a rather uniform amount over a large area. Some areas get more than others, but we get powdered sugar on the whole pancake. But lake effect snow bands are narrow. The bands may wiggle a bit here and there, but it can set up shop over the same localized area for hours. Now I've got more powdered sugar than I bargained for over parts of the pancake, but some areas are still plain. This is why you can see snow totals vary by over a foot within a few miles. Of course, powdered sugar is easier to clean up than a heaping pile of lake effect snow. A sunrise can be a stunning display, but to catch one, you have to know when it's coming. Especially here in the Northland, the time that the sun rises and sets can vary drastically depending on the time of the year. It's the Earth's tilt that's responsible for the seasons and the constantly changing nature of our daylight hours. The winter solstice in the northern hemisphere is when the sun is over its southernmost point, the Tropic of Capricorn. Of course, every day is 24 hours, but if we define it as daylight hours, the winter solstice is the shortest day of the year for us. How short it is depends on latitude. Key West, Florida still has over 10.5 hours of daylight on the winter solstice. The further north you go, the shorter the shortest day of the year is. The Canadian border has closer to 8 hours between sunrise and sunset, which is about 2.5 hours less of daylight than Key West. The time that the sun rises and sets depends on both latitude and longitude. Even on a more local scale, we see this. On December 21st, the sun rises after 8 a.m. for International Falls and sets at 4:20 p.m. Duluth will see a sunrise more than 10 minutes sooner and a sunset 2 minutes later. Minneapolis' sunrise isn't much earlier than Duluth's, but the sunset is 12 minutes later. Madison has a sunrise almost 40 minutes earlier than International Falls, but a sunset that's only 5 minutes later. Let's look at Duluth's day length over the course of the year. On January 1st, we have 8.5 hours of daylight, and it's 52 seconds longer than the previous day. The rate of daylight gained peaks around the equinox, with each day being 3 minutes 21 seconds longer than the day before. The rate flattens out at the solstice, with June 21st being only 1 second longer than the previous day. The summer solstice has almost 16 hours of daylight, then days quickly get shorter as we head through the fall. Sunrise time is almost at 8 a.m. at the start of the year, but it'll be pulling back nicely around 6:30 in March. At that time, we have daylight savings beginning, which puts us at an hour later. By the summer solstice, sunrise is around 5:15 in the morning, and without DST, it would be closer to 4 a.m. Sunrise falls near 8 a.m. in November, then we have the end of daylight saving time, sending us briefly back to a 7 a.m. sunrise. We bottom out close to 8 a.m. in December. So it's easy to imagine that if you tried to catch the sunrise at the same time as a month or so ago, you could miss it completely. And what a shame that would be.